everyone, welcome back to another lesson. Today's learning goal is I can use the standard form of linear equations. So far we've learned about the slope-intercept, which is y, if it lets me draw, y equals mx plus b. Okay, and we've also learned about the point-slope form, which is y minus y1 equals m parentheses x minus x1. We're going to learn one more form called standard form. Okay. This form of a linear equation called standard form and is used in many real-world situations. In standard form, a, b, and c are integers. Remember, integers are numbers like -3, -2, -1, 0, 1, 2, 3, and so forth and so on. Okay, so whole numbers and their negative opposites, whose greatest common factor is 1. So you cannot share any greatest common factors between all three of these numbers. A must be positive, and B cannot be. A must be positive, and A and B cannot be both 0. So, that being said, based on the definition above, circle all the functions below that are written in standard form. So this is written in standard form because these are all integers, and 3, 4, and 13 share no common factors. This one is in point-slope form, so that can't be true. This one looks like it's in standard form, but it is not. Okay? Because A right here is a negative number, and A cannot be a negative number. 2, 5, and 20 are all integers, and they do not have any common factors, and A is positive, so therefore this is in standard form. Here, A is not an integer, so therefore this is not in standard form. 7x plus 3y equals 53. This one is going to be in standard form because 7, 3, and 53 do not share any common factors. A is positive, and 3, 7, and 53 are all integers. So, linear equations written in standard form can be especially helpful in finding the y and x intercepts. Okay. Again, remember that the y-intercept is a point on the graph where it crosses the y-axis. The x-intercept, also called zeros. Okay, remember that. Okay, x-intercepts are also called zeros. So this is a 0 right here. The x-intercept is the point where the graph crosses the x-axis. Record the order pair of the x and y-intercepts below. So here we have a y-intercept of 0, 6, and an x-intercept of 8, 0. And the x-intercept will always have a y value of 0, and the y-intercept will always have an x value of 0. So a quick review about that. Here we have find the x and y-intercepts of the following equations and use the points to graph the function. So here we can always take, and that's the dog, hold on. Sorry about that. So to find the x-intercept, we just plug in 0 for y, and we find that x is 6. So therefore our x-intercept is going to be 6, 0, which is right here. And our y-intercept, we just plug in 0 for x, and we get 2y equals 6, and so y equals 3. So therefore we have 0, 3. Which makes 0, 3 right here. And we can draw a line between those 2 points. And so our line should look something like this. Go ahead and try number 2 out on your own. What you should have found is that the x-intercept is 7, 0, and the y-intercept is 0, 4, and the point, or excuse me, the line should look something like that. It says that Yarrow is going to graph the equation 8x plus 3y equals 24. Describe the following. Where will the 0 of the graph be? Remember that the 0 of the graph means what is the x-intercept. Okay, so we're going to plug in 0 for y, and we get 8x equals 24. Multiply both sides by 1/8. And we find that x equals 3, so it's 3, 0. The next question says, will 3, -5 lie on the graph? Explain. Well, if 3, -5 lies on the graph, that means that if we plug these two numbers in for the x and the y, that would get us 24. So let's see if it does that. So 8 times 3 plus 5 times negative 5. Does that get us 24? Who knows? Let's find out. So that'd be 24 plus negative 25, and it does not get us, 25, not 55, 25. Does not get us 24. So therefore, it does not lie on the graph. There. All right. Hans paid to enter a fair where he could ride various rides. The situation can be represented by the equation 5x minus 2y equals negative 30, where x represents the number of rides and y represents the cost of each ride. How much does each ride cost? So we're trying to find the unit rate, and it's really hard to figure out what the unit rate is. One thing that's not great about standard form is that it doesn't give us the slope in the way that we can see it right now. So we are going to have to change this into slope-intercept form. We're going to have to isolate the y. So we're going to start by subtracting 5x from both sides. When we do that, we get negative 2y equals negative 5x minus 30. And then we're going to divide both sides by negative 2. And remember, when we divide both sides by negative 2 or multiply by negative 1/2, however you think about it, we're going to divide everything on both sides by negative 2. That's y equals 5 over 2x plus 15, because we're dividing the negative 5 by negative 2, which is 5 over 2, and negative 30 divided by negative 2, which is positive 15. Now this gets us our unit rate, or our slope, right here. Okay, so that means that each ride, 5 over 2 is the same thing as $2.50. Each ride costs $2.50. And that says, how much is the entrance fee? Well, the entrance fee is going to be our B value, which is going to be $15. And here's the dot.